My name is Paulo Glushenko, and the topic of my paper is Exploratory Survey of Access Control Paradigms and Policy Management Engines. Let's start with the problem statement. As digital infrastructures evolve, organizations face increasing challenges in safeguarding sensitive information and resources against sophisticated threats. Traditional access control systems often fall short in addressing the dynamic and complex nature of modern computing environments. Therefore, I identified scalability, adaptability, and complexity as the key challenges in the field. There is a need for robust, adaptable, and scalable access control mechanisms that is critical to meet the ever-evolving demand and not only secure data, but also ensure compliance and facilitate operational efficiency across global and heterogeneous environments. For literature review, I would like to highlight the following research papers that were the most influential, in my opinion. Number one deals with the role explosion as the challenge of maintaining a practical role-based access control implementation in a real-world scenario where the number of roles becomes too large to manage effectively. The authors propose different approaches on how to deal with this problem. Number two and four deal with implementation of access control mechanisms in cloud and fog networks, blockchain, Internet of Things, and software-defined networks setups. Number six proposes a novel approach that uses deep neural networks to implement access control and depth dynamically to changes never seen previously. Number 9 and 10 describe how the policy management engines work. In these cases, it is AWS Cedar and Google Zanzibar respectively. These systems are very different, but they both are effective instruments to implement different access control approaches. I conducted literature review and comparative analysis of access control models such as role-based, attribute-based, and relationship-based access control, identified the weaknesses, potential vulnerabilities, and suggested mitigations. Also, I suggested a hybrid approach to combine the strengths of multiple access control models. I conducted an in-depth review of policy management engines, such as Open Policy Agent, AWS Cedar, and Google Zanzibar, and their respective capabilities. Selected the criteria for comparative analysis of these policy agents from the standpoint of their practical applicability. And also introduced some hypothetical scenarios to illustrate how artificial intelligence could potentially integrate into these existing systems. I explored the practical implementation challenges that organizations may face during the implementation and exploitation phases while basically using these access control systems, and discussed the integrations of these access control models and engines within existing IT infrastructures based on recent research. As for results, I identified useful AI applications in the access control field, such as user and entity behavior analytics, which can be used to establish baseline behavior patterns for users, devices, and application within organization. Automated policy management, which can assist in the creation, review, maintenance, analysis, identification of inconsistencies and conflicts in policies. Intelligent access governance, which is a continuous evaluation of user access privileges and entitlements against different defined policies, identification of excessive or unnecessary permissions, recommendations, changes, and automation. Risk analysis and mitigation, which can help assess the potential risks associated with granting or denying access to specific resources or systems. Deep learning-based access control, which is a relatively new approach for access control in large-scale, complex, and dynamic environments. Continuous monitoring and adaptation. AI can continuously monitor changes in the organization's infrastructure, applications, and user population. It can proactively identify potential policy violations or access control issues and suggest appropriate remediation measures or policy updates to ensure ongoing compliance and security. Intelligent multi-factor authentication. AI can also be used to enhance MFA mechanisms by analyzing contextual factors such as user behaviors, device characteristics, location, and risk indicators. And finally, natural language processing for policy interpretation, which can assist in interpreting and understanding access control policies written in natural language. It can translate those policies into machine-readable formats, identify ambiguities or inconsistencies, and facilitate better understanding and enforcement of policies across the organization. And for the conclusions, this exploratory study has systematically examined the integration of advanced technologies such as artificial intelligence and into traditional access control paradigms. And the findings suggest that a hybrid model combining role-based, suite-based, and relationship-based access control enhanced with artificial intelligence could significantly improve security, flexibility, and scalability compared to existing systems, as well as automate decision-making. Our theoretical analysis and hypothetical testing indicate that these technologies can dynamically adapt to changing security requirements and complex regulatory environments, thereby enhancing both proactive threat mitigation and compliance. The promising results from this theoretical exploration invite further empirical research to validate the proposed models under real-world conditions. Future studies should focus on developing and testing prototypes of the advanced access control systems in operational environments to measure their practical effectiveness and user acceptability. Additionally, exploring the impact of these technologies in specific sectors, such as healthcare or finance, where data sensitivity and regulatory compliance are critical, could provide deeper insights into their applicability and benefits. Thank you.